Let's take a look at how to write up this virtual pulley lab. First of all, we are given the mass lifted by each pulley. This is the load or the resistance. Now, the load is measured in grams, which isn't actually a force, but our spring scale also records the mass rather than the force. So it's much easier to compare grams to grams than it is to compare newtons to grams. So each time our resistance force, our load, is 500 grams. That will be the amount written in every part of your lab, including the next 2 pages. Now we are going to look at our first pulley. We have a single fixed pulley and no bottom pulley. This top pulley is fixed in place and cannot move up and down because it's hanging by this string right here. When we determine the ideal mechanical advantage of this pulley, we count all the strings that are either tied to the bottom weight, or if there's a bottom pulley, we count all the strings that reach upward from that pulley, either being tied to it or going around it. Here we don't have a bottom pulley, so we just count the 1 string, and our ideal mechanical advantage is 1. This means it's equally as easy to lift the weight without a pulley as it is with. So why would we even use a single pulley like this? Because a top fixed pulley acts like a direction changer. You pull down on the string and the weight rises up. Next, record the effort force from your spring scale. You'll see that this one takes an effort of about 500 grams. So write that under your effort force and be sure to include grams for the unit. Now we're going to calculate the actual mechanical advantage. We need to put the resistance force on top and the effort force on bottom. Not that it really matters here. Show your work by just showing me which numbers you divided. You don't need to put in the units because they're going to cancel anyway. And when you're done, you get an actual mechanical advantage of 1. That means it actually is 1 time as easy to lift. Next, we need to record the resistance distance and the effort distance. The effort is put in by your hand. You do the effort here. So your hand starts at the 40 centimeter mark. All of these lengths are recorded in centimeters. And your hand moves down to the 10 centimeter mark, a difference of 30 centimeters. So your effort distance is 30 centimeters. Be sure to record your units. Then the weight, if you'll notice, the hook of the weight started at 10 centimeters and rose to 40 centimeters, a difference, once again, of 30 centimeters. Now we calculate our ideal mechanical advantage. Notice this time the effort is on top, whereas last time the resistance was on top. It doesn't matter in this particular instance, but in the next problem it will. Show your work, do your math, and you get an ideal mechanical advantage of 1. The actual and the ideal may be different because of friction. Friction will often cause the actual mechanical advantage to be slightly less than the ideal mechanical advantage. You should have a certain advantage, but you get slightly less advantage because of friction. And the calculated and counted ideal mechanical advantages should be the same. So if you didn't get the same answer, you'll know something went wrong. Let's look at the second pulley. We have a single movable pulley at the bottom and no upper pulley. So with this weight, when we raise this string, the pulley moves up and down along with the weight. When we record the effort force, you'll notice that it took 250 grams to raise this 500 gram weight. Notice we always have the same load because we're using the same weight throughout the entire lab, and our effort was 250 grams. When we calculate the actual mechanical advantage, make sure the resistance is on top and the effort is on bottom. Do your math, and you get an actual mechanical advantage of 2. This means that it's twice as easy to lift this weight using this particular pulley setup than it is to not use a pulley and just lift it with your hand. If you lifted it with your hand, you would need to use 500 grams of force. When you lift it with the pulley, you only need to use 250 grams of force. The reason is any rope that goes to a bottom pulley will split the weight of this mass. So this rope segment takes half the mass of this weight, and the other rope segment supports the other half of the mass. You do count both of these rope segments when you count your ideal mechanical advantage, therefore that is a 2. Now let's calculate the ideal mechanical advantage. Your hand starts 40 centimeters and rises to 70 centimeters. That's a difference of 30 centimeters. You put in the effort, so that's where 30 centimeters goes. The bottom of the weight starts at 0 centimeters and rises to 15 centimeters. That's a difference of 15 centimeters that the resistance moved. Now let's calculate our IMA. Be careful, this time the effort is on top. Last time the resistance was on top. So our effort of 30 centimeters is on top and our resistance of 15 is on the bottom. Do your math, and once again you get 2 for your ideal mechanical advantage. You keep going and try 3 through 6. Remember, the load is always 500 grams, and when you go to count your ideal mechanical advantage, you will always count the total number of strings rising from the bottom pulley. It doesn't matter if the strings are tied to the pulley or wrapped around it. All the string segments that go up from the bottom pulley will be counted. In this example, this string segment rises from the bottom pulley, and so does this one. However, this string segment does not touch the bottom pulley, and so it doesn't get counted. Therefore, this pulley system has an ideal mechanical advantage of 2. When you get to pulley number 4, be careful because you'll notice that the measurement is in between 2 of these little lines. And not only that, but this is upside down, and yet here's 150 and here's 200, so this must be 160, 170, 180, 190. This measurement is halfway between 170 and 180, so for your value, please record 175, which is halfway in between. When you get to number 6, once again, be careful. This value is somewhere between 50 and 100, not between 100 and 150. Finally, as you keep going with your calculations, you'll notice that the actual mechanical advantage will be slightly less than the ideal mechanical advantage, especially as you add more and more pulleys to the system. The reason this happens is because the more pulleys you add, the more friction you add. And the more friction, the more effort force you have to put into overcoming the friction plus lifting the object.